His vision of nature itself was that of a human being in the presence of something godlike, and that's what he always said about nature. He was fond of talking about God. God doesn't play at dice. God is not malicious. Finally, Niels Bohr one day said to him, "Stop telling God what to do." But that's not quite fair. Einstein was a man who could ask immensely simple questions. And what his life showed, and his work, is that when the answers are simple too, then you hear God thinking.
Everything we don't know, which means it encompasses everything we could possibly
Well,
dream.
you see, maybe that's the reason why he was never really paid close attention to.
Yeah, you know, these guys win something for us by developing something specific.
All right, let's go forward a little bit, because actually this topic is coming up in subsection 6, Phil. So let's hold off. Phil, you're too advanced because we're just starting at the beginning here. So let the infants catch up with you. Let's play the first little video here. Here we go. Let's see here.
The man that he had most in mind was the astronomer Johannes Kepler, who came here to Prague in the year 1600 at the age of 28 and spent his most productive years here. Here he devised the 3 laws that turned the system of Copernicus from a general description of the sun and the planets into a precise mathematical formula. That was the state of affairs when Newton was born in 1642, that Christmas Day. Kepler, of course, was dead. Galileo had died in that year. And not only astronomy, but science stood at a watershed, the coming of a new mind that saw the crucial step from the descriptions of the past to the explanations of the future.
I chose that one because of a single set of laws, a landmark in thought, a turning point. This is, to me, this is a paradigm shift of thinking and thought. This opens up, it transitions humanity from away from descriptions to presuppositions. And I've been able to distill this from my standpoint, really realize when I'm describing something, when I'm being poetic, and when when I'm making a presuppositional statement. And so I think that this is a turning point. Just to reiterate, this is a turning point. It's a beautiful moment in history, and that's what Newton and Galileo and Kepler gave us, right?
Yeah.
I should bring up that the text spells out the 3 things, the 3 pillars that Newton received from Kepler that were so amazing. And this is how Phil and I started the discussion about 10 minutes ago. There were aesthetic issues that drove people's decision-making back then, like orbit should be circular and the speed should be constant and stuff like this. So what Kepler did is despite his own prejudices, he found out that the radius is not constant, that the things don't orbit in circles, but ellipses, that the speed is not constant, but shockingly, what is constant is the area of the spans, which is something that's totally counterintuitive and unexpected. I mean, and that lets you know that something's actually happening. Like, gee, things are locking in invariant relations, but not the way that my whatever inertial common sense stuff I pick up around me comes from. And the third one is that speed is locked to the average distance by some unchanging ratio. So this was so Bruno's sense idea is that what used to be a vague model will become completely mathematized and quantified in an actual formula for Newton. And it's when we learn this stuff in school, we learn the formulas first. But imagine what it would be like to be at the first moment in history when you actually got a constant and a polynomial, And that was a thing forever, always. And the universe followed that. Not just a law that you state in like as a principle that you read off a scroll, but as a thing that you see on the chalkboard. I mean, I wish I could go back historically to know what that transition was like. Anyway.
I agree, Scott. I mean, like I listen to younger children. It's kind of a trope that students say that, what's the purpose of trigonometry, or when am I ever going to use this, or something like that. And how do you give that young learner
St. John's?
What's that?
You send them to St. John's. I mean, everyone's dreamt what it would be like to be a student at St. John's. Oh, by the way, St. John's is the university where they take you through Western civilization, beginning with Homer. You actually make a reflecting and refracting microscope in the classroom, and you assemble all this stuff. You use the compass and the straight edge, and you make maps. I don't know if you know about St. John's. There's a campus somewhere in Northeast, and there's one in Santa Fe. I don't know where the Northeast one is.
Is it run by like?
It's in Annapolis.
Jesuits or something, or what is it?
Oh, no. But most of the people that teach there are St. John's graduates. But I mean, these like the smartest kids in the U.S. don't go to Harvard. They go to St. John's, and they actually relive. They read the text in Greek and Latin, and they relive the discovery process. Wow. Everything that we're learning in this video, they actually do in the classroom.
That's amazing.
They've got like a 60% graduation rate, and there's no grades, no grading.
Well, but the thing is, development comes to stages. When a kid is very young, you can't get that across to them because the brain cannot even computate that whatsoever. So they have to reach a certain age. So that's the same thing. Same thing in history. You can't make that kind of jump until you had other stuff that came before it, and then you could make the jump. And when they did make the jump, remember, like, it was heresy. It was a heresy to think like that. So that, I mean, that's a real compliment to them. They were able to skip over that and be heretics because, I mean, they've almost got burned in from the church.
And the other thing that makes it hard for kids is that you have to be, like Wittgenstein says, you have to be sick in order to experience the cure. So unless you're actually like kind of a little bit perturbed and possessed by the puzzlement of the whole thing, and you actually feel an internal tension due to the inconsistency, your cognitive inconsistency becomes emotional. Those are the people that really get the leaps because they're hungry for the medicine. So when they see they're like, holy shit, yes. And then there's an internal linking, and then there's the ecstasy of consistency.
I think showing kids and letting them who are natural scientists and naturally curious, you're always on the verge of that question. And I mean, they're ready to look at things and say, what's holding it together? And when you start to give inclinations and hints, and it's, something within their grasp, well, not like Phil is saying, not a polynomial they have to solve, but something that can be reached mechanically in some way, or manipulated, then, then I think you have the motivated person ready to learn, slingshot. But you need a curriculum to really make it ideal. I mean, university is like a slingshot effect where you throw someone around with the power of what you've already collected, right?
Well, but you also have to have a sense of daring because, like, it's kind of like mountain climbing or anything. Sometimes if you're a timid person to any degree, what happens? You come up to the edge and you're awed by the fact that this is like wonderful, whatever, but you're afraid to jump. It takes nerves also to make that leap. And that's what you got to compliment them for. I mean, to the degree that Galileo was, well, he was also naive. He was ready to almost face the gallows, right? In other words, like most of us would say, shit, this is not worth it, right? So in some sense, you see that in the arts as well. Some people would come and be very sort of avant-garde, move to the edge, and they said, no, I can't deal with that myself. And they actually back off, or other people make the leap. Because anytime you cross a big gap, you have to make the leap. You can't.
I think of kids as being fearless in some way.
Yeah, you have to make a leap because everybody's gonna think you're a fucking fool, because like that's just unimaginable. Why would you do this, right? And they face that.
it's why you want the child's mind, because you don't have predetermined answers, but you know that fitting things together is something you're built to do. And when someone holds up something for you, you don't know it's impossible or not, right? It's just like, oh, what is this? I'm going to take it apart and put it together. So yeah, it's the attitude to take when you're doing it. I didn't know people, who was opposed to Newton's methods. I wasn't aware. Was there a previous segment on that I missed? Was there some opposition to Newton?
No, look, there was a part that, there's a part that he doesn't talk about. There was a part that, yeah, he had a very secure job. Like, people loved him. But there was a part that he got so much flack from the Academy of Science, in fact, that he withdrew. And that's why he spent so much time. It was this other guy who wanted to work out how these planets move. And somebody, I think it was Hoyle, somebody suggested, well, maybe you should talk to Newton. And then he went to Newton, and he asked him, he said, oh, yeah, it's this way. It's could you show me? And Newton says, well, I haven't quite worked it out, but I'll show you. That's why he wrote the Principia Mathematica, because he withdrew because he was so self-motivated. He continued his methodology, but he didn't want to face the public in that sense, the other public, not the admirers, So in a sense, he had a lot of slings and arrows thrown at him as well, not just the admiration.
Yes. Well, speaking of a ready-to-be impregnated mindset, in this next video, which he leaves it out of the video, but in the book you see it. So Newton had already come up with his model. He saw that the moon was like a ball that someone had thrown very hard sideways, and in fact, it was thrown so hard that it never fell. It was going so the question that he was trying to answer is, what is the force that's pulling that sideways thrown baseball down? And
they got him. They kind of got him because he never explained what force was. He just only explained the calculation of how it works. They say, well, what is this force? And he never explained what gravity was. Oh, I love this.
The 2 years after Newton graduated at Cambridge, 1665 and 6, were years of plague, and he spent the time, when the university was closed, at home. Here he struck his vein of gold, mathematics. He invented what we now call the calculus, which Newton called fluxions. Newton kept fluxions as his secret tool. He discovered his results with it, but he wrote them out in conventional mathematics. Here Newton also conceived the idea of universal gravitation and at once tested it by calculating the motion of the moon around the Earth. The moon was a powerful symbol for him.
I deduced that the forces which keep the planets in their orbs must be reciprocally as the squares of their distances from the centers about which they revolve, and thereby compared the force requisite to keep the moon in her orb with the force of gravity at the surface of the Earth, and found them answer pretty nearly.
The understatement is characteristic. His first rough calculation had in fact given the period of the moon close to its true value, about 27¼ days. When the figures come out right like that, you know that the secret of nature is open in the palm of your hand. It's a key that you've put into the lock and turned it, and nature has yielded in numbers the confirmation of her structure. But if you're Newton, you don't publish it.
The reduction of all that complexity and mystery to inverse square. And it's such a good example because it has such little, all it has is a single constant, and the rest of it is determined by the values. So you don't have to do anything. You just let the distance will supply the force. So the distance squares, you divide by the square of the distance between the things. It's so the elegance in the minimalism of the addition to the formula is so attractive. Like E equals MC squared. Everyone wants that on their T-shirt because it feels like it's like the whole Torah wrapped up in a single syllable. Something you put it on a tattoo. It's like you have the whole thing contained in something tiny. People love that.
Yeah, but I do have a problem with it in a sense. But he's had that secretive mind, right? In fact, he didn't want people to know the secret of his knowledge, which is calculus, right? And he actually showed it to people in traditional mathematics, right? And he was surprised that Leibniz discovered calculus independently. He said, well, how could that be? How could there be a mind that could actually discover this other than myself? So he was kind of egotistical too, you know? So maybe if he was a little bit more open and show people the math, his secret potion, you could say, maybe there would have been more accepting. So part of it was also his fault. Now maybe he had a right because he was already harassed by other people. If he shared this secret, and they wouldn't understand it, they just harass him even more. I don't know whether he just wanted the glory and not share with others, or he wanted to just, in a sense, protect himself from further criticism.
Yeah,
Come on, Scott. Go, Scott.
I have a question about that, Dave. So the rise of industry, and then the importance of invention, and then so telescope manufacturing, and then he makes discoveries in light and all this other stuff. So my question is, were people hiding their patentable intellectual property before capitalism or not? I'm just wondering.
Yeah, and also mathematicians were hiding their techniques traditionally for factoring. You know, this is how
the guild stuff.
Yeah, and this is how you kept your power and authority, that you alone had the way. It's like cryptography. You know, I can break the key, no one else can. So I don't see that he was doing anything wrong, except you're saying he wasn't contributing to science for science sake, and that he couldn't believe that after all his work and the complexity of it, dealing with physical objects, that someone could come up with a purely a priori mathematical calculus. Like, that's absurd, because that involves just studying numbers. So who knows how Leibniz did it? It is a little suspicious, right? So, but then again, that's the genius in that field. Is Phil frozen?
It happens too, though, in in contemporary academic fields too. I mean, there's been academics thrown under the bus, and then later on discovered that they had something of value, and so the world turns. That's where you get Max Planck's famous quote about science advances one dead person at a time, kind of thing, right? So I mean, it is a changing of the guard, and I think that David and Scott are absolutely right. It's a power thing, and I'm spending a little bit more time in economics, right? And then I'm spending a little bit more time thinking about what capital means. And capital can be held within in knowledge structures too. I mean, the institutions of academia have a certain amount of power, and that power is in the knowledge. And so, it happens between departments. It happens between colleagues. It's a very complex human interaction, I think.
No, well, I think it also.
Part of their capital is their position, their prestige, and their role at the moment, which is something that will be sacrificed by not being cognizant of that, the value to them. Sorry, Phil, go on.
I think it also has something to do with him being an alchemist. Because when you don't share the secret of the calculus, then in a sense, you're also a kind of magician. Like, how in the hell did he do that? You know what I mean? So that magician part, in a sense, I think was a kind of like the old magic thing that happens. I think it was also related to that in some form.
Okay, so let me say this then. Let me say as a fundamental conditional, you'd say the thought begins with what if? what if I could actually make gold out of mercury, right? What if I could actually do that? What if I could actually show some sort of structure in the Book of Revelations? What if I could come up with my own way of describing the universe that took into account an infinitesimal like kind of mathematical structures, his fluxions, concept, which by the way, I think fluxions is I say, let's bring fluxions back. I think it's less
catchy name, right?
Oh, cool. It's like, the kid's not going to say, oh man, I got calculus. It'd be like, all right, you get.
Fluxion.
Yeah, there's an uck in fluxions, and for that, that's enough reason for people to think it's attractive. So anyways, so in this, that's enough. It's time for some comic relief. This is the funniest of all the parts of the series coming up. I think
you should show the part about the light. I thought that was
that's it. That's what we're doing. It's coming right now.
Okay. Well, as you bring it up, I just want to say that I'm not sure his hiding things also is that sinister as much as this is the way he does it. And you don't always let everyone know the way you're doing it. There's no reason to, because the results, not the process, may be the thing you're trying to get to. And also, you don't even know the value of your own process necessarily. You don't know the value of any particular discovery when you make it. Look at the guy who figured out about the neutron. When they discovered the neutron, that story, right? It's like, oh, fuck, there's neutrons. That explains the atomic table. Now we know the periodic table. No one's going to fucking care. They don't do anything. Yeah, right.
Well, but remember, he was a lonely and secretive boy. So the psychology has something to do with that.
Freud wasn't there.
Now, of course, the fact that the prism gives you colored light is at least as old as Aristotle. But alas, so were the explanations of the time. Because they had this extraordinary quality. They simply said, the white light comes through the glass, and it's darkened a little at the thin end, so it only becomes red. It's darkened a little more where the glass is thicker, so it becomes green. It's darkened a little more where the glass is thickest, so it becomes blue. Marvelous. Explains absolutely nothing. Sounds very plausible. The only thing that it doesn't explain, as Newton pointed out, the moment he let the sunlight in through a chink through his prism, was this. The sun comes in at this end as a circular disk, but it comes out at this end as an elongated shape. Everybody knew the spectrum was elongated. That also had been known for 2,000 years. But it takes a powerful mind like Newton to break his head on explaining the obvious.
It's the dimming, the greater the angle in the prism, the more it dims, and so it changes color in this plausible additive or subtractive like pigment style way. And then no one had thought to look at the obvious thing, which is like, oh, by the way, has anyone noticed that the projection of the light on the floor is like 10 times as long as what was a dot a second ago? And then only a simple-minded person would be such a literal geometrical thinker to think that separation like that means separation internally.
Yeah, but you didn't show the second part. The second part was really the important part. Then he took the light, the red or some other color, and he tried to break it again, and it wouldn't break. I mean, that is actually the crucial statement of reinforcing what he already discovered, right? Because if he hadn't done that,
that's actually the very next video.
Oh, okay. Well,
and Newton said that the obvious is that the light is not modified. The light is physically separated. That's a fundamentally new idea on scientific explanation. Quite inaccessible to his contemporaries. Robert Hooke argued with him. Every kind of physicist argued with him, until Newton got so bored with all the arguments that from that time on, he really refused to have anything to do with debate at all, and certainly with the debaters like Hooke.
I know. So the most beautiful sequence is coming up with the lights is coming up, but I wanted to slow down because all the experts in the field were so in love with the like colored materials story. Like there's got to be some pigment like. I mean, they must have been thinking like this because we know what it's like to have colored glass. We know that colored glass makes colors. So when you see white light coming out as a rainbow, you're thinking it's got to be that there's an invisible but tint-like substance inside the glass that's lending or modifying or changing the light and tweaking it. Do you see? So it was a materialist conception, and wavelength is going to blow all this away into another dimension. It's so exciting.
It's a terrible revelation because white is not a color anymore. White is just a jumble. It doesn't tell you. You know, how could that be? We've been looking at it forever, and now all the colors around it. And like, what's the difference? They look the same, and you had to have something concrete, like Phil's saying, like the next experiment, to show it doesn't behave the same way. That was a brilliant test. And if they would have just shut up and not yelled at him long enough, he could have showed them. You can understand him separating himself from the crowd.
Well, I sort of told you that he not only had his admirer at the college, but he had a lot of people who didn't like him for various reasons, because he broke the rules.
I don't see it as liking. I don't see it
but he broke the tradition of what everybody believes. So that's why he withdrew. I told you he withdrew and did his own thing. Like, forget it. I'm not going to debate with these guys anymore. It's not worth my time.
It sounds more like he was brought up in a reclusive way. He developed his theories in a reclusive way. Yeah. And when he had to confront people dialectically, he's like, this is not my way. I mean, I showed you what's right. Leave me alone. He wasn't up to that part of it, which is okay. You can't be good at every aspect of science. Like, he's not Carl Sagan. Okay.
No. I'm saying that he probably knew that at least on one level, he's way above these guys. Why even bother arguing with them, right? So it's just not worth it.
Well, that isn't a scientific attitude you're accusing him of. That's just,
I think that was his attitude.
Personal attitude.
Yeah.
Yeah. I wonder what he was like if we would have wanted to have a beer or, a Frankfurter with him.
Okay, here comes
He treated his students that way. I don't think he treated his students that way. He's not a friendly guy.
No?
I don't think so.
He never married?
I don't think so.
No, he was a virgin his whole life.
Oh, man, this is not a happy story. I mean, come on. What are you expecting? Not a happy story.
But let us begin at the beginning. In Newton's own words, in the year 1666, I procured me a glass prism to try therewith the celebrated phenomena of colors.
And in order thereto, having darkened my chamber and made a small hole in my window shuts to let in a convenient quantity of the sun's light, I placed my prism at his entrance, that it might thereby be refracted to the opposite wall. It was, at first, a very pleasing divertisement to view the vivid and intense colors produced thereby. But after a while, applying myself to consider them more circumspectly, I saw that the light tending to one end of the image did suffer a refraction considerably greater than the light tending to the other end. The true cause was detected to be no other than that light consists of a heterogeneous mixture of differently refrangible rays.
The elongation of the spectrum was now explained by the fanning out of the colors. Blue is bent or refracted more than red.
Then I placed another prism so that the light might pass through that also, and again be refracted before it arrived at the wall. This done, I took the first prism in my hand and turned it to and fro slowly about its axis to make the several parts of the image successively pass through the hole, that I might observe to what places on the wall the second prism would refract them. When any one sort of rays hath been well parted from those of other kinds, it hath afterwards obstinately retained its colour, notwithstanding my utmost endeavours to change it. I have refracted it with prisms and reflected it with bodies which in daylight were of other colors. I have intercepted it with a colored film of air interceding compressed plates of glass, transmitted it through colored mediums and through mediums irradiated with other sorts of rays, and diversely terminated it, and yet could never produce any new color out of it.
If light were modified by glass, the second prism should produce new colors. Newton called this the critical experiment. It proved that once the colors are separated by refraction, they cannot be changed any further.
But the most surprising and wonderful composition was that of whiteness. I have often, with admiration, beheld that all the colors of the prism being made to converge, and thereby to be again mixed, reproduced light entirely and perfectly white. Hence, therefore, it comes to pass that whiteness is the usual color of light, for it is a confused aggregate of rays endued with all sorts of colors as they are promiscuously darted from the various parts of luminous bodies.
That letter was written to the Royal Society shortly after Newton was elected a fellow in 1672. He was rather proud of his achievement.
A naturalist would scarce expect to see ye science of those colors become mathematical, and yet I dare affirm that there is as much certainty in it as in any other part of optics.
There, the bugles begin to play, because now even very hue itself has become a quantity. And we've also learned something about light. I mean, at the beginning, they thought light was springy or rubbery, and that by wrenching it through different densities, you could pull it and change it. And it turns out that no, actually, you were just, it brings the law of identity into colors. Particular colors are always themselves, and they're not bendy and springy, and you can't change their color by changing their direction. It doesn't work. So light is different, and then color became something that they later find out was a quantity. Anyway.
Yeah, but I don't think he explained why between the various hues there's a area in which is sort of a little bit confused. Did he try to like focus on, you know, there's a transit. It's not like there's a sharp edge between them, right? Like red, and then it gets sort of like dullish red, and then it becomes green and so forth. Why didn't he try an experiment in which he, instead of looking at the red part of the red that's really red, try to focus on that in-between zone, which is smaller, and try to see if he could break that up? He never did that. Not according to this film, anyway. He didn't try to explain that part. Okay, maybe he couldn't explain that, but he didn't even try.
Well, I don't know.
Well, maybe he did. Maybe he did. Okay.
We don't know. We don't know. We haven't seen the bullet list of every named color that he checked. But he probably checked red, orange. I can imagine. In fact, he could have a whole rat race of prisms set up in the room and just sit there at the main one and just look at how all the 1,000 branches are remaining the same as he goes through it. Even as he travels from red orange to red orange orange to orange yellow to orange yellow.
Yeah. Well, he did a second slit where he took a part of the spectrum and allowed it through, and then he put a prism in at that slit, and it never split it up into other colors. And then he could move that slit across the whole spectrum and see that he was never getting anything set in.
That's what I meant to say. All right, now, so time for some comedy. Here's the second funniest joke from the episode.
Only in 1684 did there arise in London an argument between Sir Christopher Wren, Robert Hooke, and Edmund Halley, as a result of which Halley came to Cambridge and said to Newton, what would be the path of a body that moves around the sun under a force which falls off as the square of the distance? Why, of course, said Newton, an ellipse. My God, said Halley, we've all been trying to prove that. Show me. And Newton said, well, I don't exactly have the proof. I'll send it to you. It took 3 years from 1684 to 1687 before Newton wrote out the proof, and it came out as long as that. And as a system of the world, of course, it was sensational from the moment it was published. It is a marvelous description of the world subsumed under a single set of laws, but much more. It is also a landmark in scientific method. We think of the presentation of science as a series of propositions, one after another, as deriving from the mathematics of Euclid. And so it does. But it's not until Newton turned this into a physical system that modern scientific method really begins.
So I thought it was hilarious that he said, "I'll be right back with the proof." And then it ended up taking 3 years. But that reminds me of Kant when he wrote a letter to someone. He said, "I came up with this new idea. I'll be done with it in a month." And it was 10 years. And then it just reminds me of the parts in the films when the person is transitioning from their normal self into their hero self. So right when Rocky starts working out and making the egg shake, I like that part of the movie. I'll play that when I'm depressed. Or the part in The Fly where he starts exercising. Remember David Cronenberg's The Fly? He's doing the somersaults on the bar in his house as he's halfway between human and fly. He's super strong. That's very exciting.
It just shows that even a conceptual understanding takes a lot of work to work out the details. You know, I mean, he already knew. So he said, "Oh, of course, it's the ellipse." He knew, but to actually show the proof, you know, I saw the movie, the Man Who Knew Infinity, which is what's his name? The guy at the turn of the 20th century. Anyway, he knew a lot of things, and of course, his teacher, not his teacher, but his person he worked with, his advisor, said, "Well, how do you know these things?" And of course, he being a Hindu, said, because God told me," which is hilarious when you say it that way.
Are you referring to Ramajan?
Yeah. What?
Ramajan.
Yeah, Ramajan, right. And so he said, "Yeah, but we don't need you knowing it, whether it's from God or anybody else. We need you to actually prove it, at least in the Western tradition, right?" And he had to work very hard and made many errors, and, you know, he had to be corrected and all that. In fact, Ramajan was such a mathematician, was so sort of confused that people refused to work with him. And only Thomas Hardy decided, you know, he saw that he was a genius. He said, "I'll work with you." And of course, he turned out to be a great genius, but you know, Thomas Hardy was a pretty damn good mathematician, and he forced him to produce the proof, you know, which was very, very difficult, much more difficult than "I know because God told me," right? Okay, whatever.
That's right. Yeah, the devil is in the details, and it's a completely different order of knowing.
That's right.
I mean, and it may be the case that your intuition is wrong. You don't really know unless you sketch it out and you see all the gears meshing together exactly. Then you know it actually works. Which is why the great Ed Alaire used to tell us, if you can't write, you can't think. He said, if you don't know how to write, you don't know how to think. We thought, oh, that's not fair. That's not fair. Anyway. All right, so here's this is Phil's favorite part is the one here. This is where we talk about the issue of the interior of the occult reality versus what science does, which is just set up variables and relationships, you know, ratios, external things.
When Newton was challenged on such questions as, "You haven't explained why gravity acts, you haven't explained how action at a distance could take place, or indeed, you haven't explained why rays of light behave the way they do," he always answered in the same terms: "I do not make hypotheses," by which he meant, I do not deal in metaphysical speculations, I lay down a law and derive the phenomena from it. Exactly what he had said in his work on optics, and exactly what had not been understood by his contemporaries in optics. Now, if Newton had been a very plain, very dull, very matter-of-fact man. All that would be easily explicable. But you see, he was not. He was really a most extraordinary, wild character. He practiced alchemy. In secret, he wrote immense tomes about the Book of Revelation. He was convinced that the law of inverse squares was really already to be found in Pythagoras. And for such a man, who in private was full of these wild metaphysical and mystical speculations, to hold this public face and say, I make no hypotheses, that is an extraordinary expression of that secret character. Well, the public face was very successful.
It's actually a perfect little clip to put in right beside what Scott's last point was. The idea that if you can't write it, you can't think it. And I think in terms of a socially accepted, I guess, like presupposition, absolutely, right? I mean, you're not invited to the table if this is what we're trying to establish and work towards something that is the proof. But I think that the that substrate of mental ease, of thinking, imagining, reorganizing, is something that every genius and layman alike have to some degree and capacity. And so, you know, some people are just more creative than others, and I think that's personally, I think that's the wellspring of where true genius emerges from. I had this idea of a prompt for society, and say it's like a meme, right, that you put on social media, and you say, and of course everybody knows because we've just been talking about Newton, right? But the meme would go something like this: I make no hypothesis is a bold-faced lie. The man of genius was a practicing alchemist, a secretive man of his work, and an engaged reader of the Book of Revelations. Who am I? Like, you know, it's kind of like a fun, you know, who am I? And so we know those talking points. We know who that is. And even if we didn't have a series on Brunelleschi, or even this particular episode, we would know who that is, right? But I want more people to know who that is. And I want people to know the value underneath that statement of, I make no hypothesis.
Yeah. So, and I like the point that it connects verifiability with public presentation, and that's right, because verifiability is what's public. So if I have a private conviction that Revelations really means this particular sexy, emotional, metaphorical, mythical fantasy I have, the relationship to that fantasy is different than the relationship I have to an object that I can hand you, like an octopus hands a pattern of itself to another as an object that can be passed around and expected. So if I can write my thing out in steps, where if you nod your head at 1, 2, 3, 4, 5, you have to nod your head at conclusion. Yeah. If I can unpack it that way, then I've done it. So Newton just realized that he can't turn his alchemical convictions and his Christian convictions into something that can be tested. But science is all about what's tested. So he was extremely proper when it came to scientific publication, because he realized that guessing that light was like chewing gum, and that's why he changed its color, was wrong, and he proved that it was wrong. But to go beyond that and say, moreover, not only does this experiment show something, it also lets us in on the secret of what nature's like on the inside. He couldn't do that. He couldn't tell us what light looked like on the inside, so he refrained from it. So I think that, well, gee, it just seemed like a really noble thing. So he was super mystical on the inside, and then super proper on the outside, and I can't think what better way to be.
Well, that's exactly my point, and I'd actually like, you know, as a group, to spend a little bit of time on that, because I think the idea is, like, Scott, you're absolutely right. There's this verifiability that happens, right? If I come up with an idea, I go out into the group. The idea either survives or it doesn't survive. It doesn't mean that the idea doesn't have potential. It means maybe I have more work to do, right? And with Newton's particular kind of genius, he's fine to be in that in that sort of space for such an extended period of time. Take the analogy of the solitude. We're not solitary creatures, right? This is why when you go into a prison situation and they throw you into solitary confinement or something, this is horrible. This is terrible, right? Now, it's ironic to me that the wellspring of that emergent phenomenon that's genius, right? This base conjecture substrate starts in isolation, right? I mean, and then it bubbles up into a eusocial sort of reflection. I think that's just tragic and beautiful at the same time.
Yeah, but I think sometimes it's overly emphasized that the proof is necessary, which it is, at least in science. But you got to remember, there would not be a proof unless there was imagination to begin with.
That's exactly.
So therefore, you would have this sort of so scientists who are following the rules and panning out proofs, which are actually just raking over the coals of what the genius who had the imagination produced. So therefore, you also have to honor that stage. You know, as an artist, I understand that, right? Because there's actually two stages. There has to be the eruption, which I would call the vortex or the volcano, and then you have to then gather what spills out and put it together in some understandable way. So I understand that, but it's the two-stage process, and in many ways, the gathering is more difficult, as you pointed out, because it took him a long time to, in a sense, gather what he already knew, right? So in some sense, but remember, you can't have the second stage without the imagination to begin with.
And the prior stage before that explosion is the fact there has to be some huge built up amount of energy, something that's going to shoot all that rock up into the sky. And this is why Newton's the one who talked about standing on the shoulders of giants. It's all, the groundwork is there enough for a person who, when they shut out the outside and come to contemplate what's already there in conflict, there's something to do with that, channel that, like you said, with a burst of imagination. Say, I'm going to try this. Like, there's no one else in the world that can take a central force and prove an ellipse. Like, there's nobody. So,
well, sometimes imagination go wrong too, because you have volcanoes that erupt, and it's like there's nothing to be gotten from it. So in some sense, pure imagination is also not productive. You have to have the second part.
We're not seeing what comes out, not being able to recollect, even though it's productive, not knowing, well, that's a good product, right?
So here's a good question. So there's a few things still existing in mathematics that everyone knows is the case, but they can't prove them. So what are the recent conjectures and theorems, David, that have been famously discovered in the last 10 years? That something was waiting for 99 years before it was solved. Which ones were they again?
There are gazillions of this. An ABC hypothesis about
two of them were solved in the last 20 years, and they made headlines in the New York Times, but I can't remember which ones they were.
Oh, Fermat?
Yeah,
that was a big one because he claimed to have done it himself. When he wrote the theorem, he claimed to have proved it.
Yeah, I also am interested in asking the question too. Like, when could you make this discovery that actually turned into new knowledge? Is it the eruption and that produces a kind of technical device that allows you to actually pan out what that eruption's about? Like we talked about a finer prism that could actually, in a sense, maybe investigate the gray area between red and yellow. I mean, like, or is that instrument a production that you also have to do separately, whether that's instrument itself, a technical instrument itself, or language, because he had to invent a mathematics that, in a sense, to describe it. Although after he did it, he could write it in traditional mathematics.
Yeah, technology advances science as much as science advances technology. And
Well, also the language.
I'm glad I recorded that, Phil. You just organically flowered all the prongs of science. You have experimental science, and then theoretical science, and then the formalism, which is the language that we use. It's the mechanics that allows us to run our transformation rules, and that's everything. So, Phil, just by thinking aloud, you've unpacked the three essences of scientific method.
Well,
look at that.
but also the instrumentation too, not just the language, the instrumentation.
I got one better. I got one better. So what? So Phil, see, the thing is this is the artist in you, right? So no, seriously, right? So I have an idea for your next piece, right? It's going to be very easy. You just have a white canvas, and the name of the title of the piece is Instrumental Color.
Right. No.
Dedicated to my friend Newton.
No, you're right. I'm not interested in dusting up the gray areas of Newton. I got my own thing to worry about. But I will tell you, I'll tell you the story about that in terms of language. A lot of people now sort of like the people who doesn't understand Jackson Pollock, because he just spilled the paint all over. Like, what's that about? He was inventing a language of action, right? In fact, it took a critic to finally realize painting was no longer on an easel. You did this, said that. He said painting has become an arena of action. So how do you produce action rather than just like repeating the character over and over again so it looks like it moves, but actually portraying the energy of action in the canvas? And once you realize that there's another dimension that other people weren't doing, they were representing things or even representing thoughts.
That's right. Yeah, that's right. Modernism was a great explosion of novel approaches to the act. Like, remember the surrealists wanted to bring in what was beyond human planning and forebrain by dropping things from a distance so it would fall on the canvas in a random way. So you drop a string, and the string would land like this, and you say, "Look at that! The air currents made that shape." So so I brought the chaotic and the extramental into the thing.
Yeah, going back to the Jackson Pollock, I have to point out, I don't know if you guys ever watched that series with Charlie Sheen, but 2.5 Men, and Berta comes into the room, and it's just a mess. One of Charlie's binges the night before, he's like, "My God, it looks like a Jackson Pollock in here." Or the white light, or you see this kind of thing, right? So there's a whole different kind of cultural spin that and I bring that up and make a point to say that make it a little bit more serious. This next point is to say that scientific discovery, you don't know what the implications are going to be, right? I mean, one simple mathematical proof can change the world in so many manifest ways that the mathematician has no idea.
Yeah.
What will result from what he's discovered, right?
Well, as a matter of fact, wasn't there a mathematician who did something, and looking back, and somebody else says, "I think that might be describing a graviton," right? I mean, it wasn't the guy who thought about the idea of a graviton, but actually he was doing something else, and there's a little equation that came out, and he said, "Well, maybe that is actually a language that is suitable for describing what a graviton is." Even though we don't even know what the fuck a graviton was, he says maybe that's a language is needed in order to even talk about it.
And what if reality is just coherence all the way down? It's just it's pure set theoretical coherence all the way.
You're talking about the matrix now. You're talking about the matrix.
I vote for
David.
When we discretize things and we turn them into languages and formalisms and formulae, It's a little bit like magnetic poetry, where you throw all the words up onto the refrigerator, and it can create something beautiful, and then you have to validate whether it has anything to do with a system that you're going to use it to describe or not. I mean, there are so many theories, and there's only so much matter, right? So there's a lot of complexity you can bring into mathematics. When something can actually be comprehended by a human being, there's a miracle to begin with, okay? Like, we can understand just so few things, and that's our mind, once again, trying to wrap around that incredible complexity of reality, which we have to reduce to yes or no, green or red. I just like, maybe there's something between the green and red. It's a little yellow, maybe, I don't know. And, and I can only see 3 colors, but I'm going to tell you all the colors. And yet we're trying to describe reality.
Well, you guys don't want to hear about Anaxagoras. I told you.
I think we do, Phil. I mean, you keep bringing him up. It's not that we don't want to hear about him, but it doesn't seem like an open-ended question. It seems to be kind of like a trailing, sort of point, right? And so we're waiting for the point, and I think maybe, or at least I'm like, yeah, I agree with you. That's great, good idea. But it's almost like Phil's putting up his hand saying, you guys didn't quite get it right. You guys as a society didn't pay attention enough to this particular guy. You need to look here.
What I'm saying is that he was talking about a proto-language. A language is not a language yet, but you have to understand that there is something here he's referring to, that you need a language to describe the thing. And before you could describe the language, it has to be in the unlimited category, right? That's what he was saying. You can say, well, yeah, but he doesn't have a mathematics. Well, of course he doesn't, because it's only a proto-language.
That brings up to David's point, though, right? And it doesn't dismiss your point, Phil. It just brings up, I think the analogy was so beautiful. I thought David's point before about the fridge was amazing. Because it's right. We have these discrete entities that we put up on the fridge, and we somehow make sense of them. So what if what you're describing is that it's beyond our capability to just imagine the imaginable and just say, guys, why don't you just go to school and imagine the imaginable, and we'll all be great, and then all this emergence will come out of this.
Come on, you're kind of almost expecting that the Neanderthal man could speak eloquently about E = mc squared, but he might have some sort of like proto-language in his grunts or whatever he is, that's trying very hard to describe something that is like awesome, but he can't speak it, but he's trying to. Like, give us a break. That's what poetry is about.
No, I got a good example.
What you can't speak about.
Okay, all right. I'll follow that thought thread for a minute. So there's linguistical studies where you're studying different populations, more obscure populations that orient themselves in different ways, right? So if we I guess like the dominating hegemony and the way of thinking orients ourselves in like a grid pattern, there's, I think, certain populations that think in relation to where that particular mountain is. That's the direction. There's not a north, east, west, and south, right? That doesn't exist. They orient to where their particular mountain range is, or where their particular geographical location is, right? Or their landmark. And I think these are fascinating, right? They tell of a civilization that maps their reality in a slightly different way.
Yeah, that's a good point. Okay, communication is important. So even if the Neanderthal has a real grasp or apprehension of something, he's not going to be satisfied until he can package this as a sound string that some other Neanderthal is going to be like, oh, I see what you mean. You're talking about and then repeat it back in a way that shows the intersubjective agreement. So that's what this process is. We have an infinity of experience, and then succeeding filters that narrow it and narrow it. And then the final narrowing is coherence with our overall worldview, fitting into a system. And then there's this concern with certainty, which is the next video coming up, because science seems to have be interested in certainty and provability. It's like answers have to be calculated and inferred with the same necessity as a necessary conclusion. So if 1 is true, 2 is true, therefore. So so a lot is being left out of the science model building, and what's being left out is stuff that doesn't make it into quantification and calculation. But anyway, I was touched by this next little part here because Newton seems to be like the kind of like a mouthpiece for like this ethos of like cleanliness, minimalism. He's like it's an Occam's razor thing. Anyway, I don't want to say anymore. I'm saying too much here.
Yet in his private writings, Newton was not so arrogant as he seems in his public face, so often and so variously represented.
To explain all nature is too difficult a task for any one man, or even for any one age. 'Tis much better to do a little with certainty, and leave the rest for others that come after you, than to explain all things by conjecture without making sure of anything.
It's a humility thing. I mean, there's arrogant people that have a single model that explains everything, and they build a religion around it. Then there's people like Locke and Newton that just want to get this one part fitting together perfectly, and then that'll help the humans of the future. Because I mean, this ball bearing is going to be used in automobiles, so it doesn't do any good to have like a crappy gravel. Let's imagine that ball bearings were gravel originally. Yeah, you can make a car with gravel ball bearings fittings on them, but see what I'm saying? So these guys are heroes to me because they're antiseptic, careful, methodical, and they don't care about getting the whole picture themselves. They'll leave that to the overman down the road.
Well, it's sort of, sad, and that there is this ideal, and he knows we can only make these small steps forward, and there's so far to go. It's really, really touching to picture Newton looking at the world, the guy who made the biggest steps that anyone's ever seen, technically, looking at things so humbly. And then you compare that to Gauss, and the mathematicians who say, "No, we're going to solve everything. In fact, we're going to put a handle on this cranky, and it'll all come out here. We'll just prove everything." That opposite, those guys, it's a different hubris there.
Yeah, but if that indeed is humility, then in a sense, it almost seems like science, at least a certain kind of science, has taken the humility and turned it around, and only took the certainty part and not enough about, only a small part. So to me, it seems like problematic in that sense, because what I was going to say is that all of this, in a funny way, has made Western society arrogant in its hubris to, like, in a sense, look down on all the other inferior cultures. I'll put inferior in quotes because they haven't had this precision, and we made a mistake. The precision is the same as something that will reach or try to reach the whole. So maybe it's better, and maybe in some ways it's better, and I'm not going to say it outright, to be an American Indian and in a sense have a whole system and which you could actually feel like, you understand while you don't understand, rather than just say, I just got this small piece, like looking, I actually did an artwork that talked about that. When I went to New York, I wanted to paint big, but it was so expensive that I only had a very small room. In fact, anytime I do art, I have to put my bed aside and fold everything and do this to have even enough space to do something. So I only had enough for a piece of paper. And what I invented what I call conism. And what I did was I made these glasses that was the opposite of a telescope, in which I closed it down. There was only a tiny little hole at the end. I attached it to my glasses, I wore it, and then I could only see a small part. And I try to figure out what in the hell am I doing? And I tried to actually make sense out of it, and I couldn't. And then what happened was, after I took off the glasses, that's when I had some understanding of what the damn thing was. And what I did was I only did half of the picture, and I did on the other half, and then I finally made a quick skeletal diagram of it and placed it on the other half. At that time, I was thinking about Plato, except I put it in the wrong side because if I was thinking about Plato, I should be putting it on the left side. So the ideas already came before the thing. But in fact, the idea, the understanding only came afterwards. When I took off the glasses, I could actually see the whole thing. I say, to make some little analysis of what the heck it was. So that was interesting. I would not want to live my whole life in these cone glasses, because I wouldn't understand a damn thing. Maybe
I thought of the Mennonites and the Amish when you made your first point. I imagine what it would be to live in a community like that where there's no television and really believe that the Bible was the word of God. There'd be a sense of completeness and fulfillment. There'd be no like this anxiety and mystery and wonder, because this is God's word, and everything that exists is a wheat field, home, breast, and Bible, and that's it. And so it's very satisfying to live. And also, God is infused at all of matter, and emotions and beings are connected somehow, like in the alchemical medieval way of correspondences. I think there's a lot of mental health in ignorant, poetic, metaphor-based communities.
Which is something we have a challenge to accomplish in our time, right? Now, with Phil, were you talking about 20th century science claiming to encompass explaining everything
well, I think 20th century science become more sophisticated with the incompleteness theorem and chaos principle and so forth, and even a statistical, because multiple perspectives. But I'm thinking more of logical positivism, in which, like, we pretty much got it. We just have to work out the little detail that's left, right? And that's when Einstein blew up the whole damn thing. Right? No, we're not even close to that. Of course, he was trying to save Newton, but in fact, he caused an eruption.
Well, I'm trying to see Scott's point in terms of where we are, which is a science that's sophisticated, highly developed. It doesn't always recognize its own boundaries, but like you said, has areas where it has found there are necessary limitations of what can be expressed or proved, and then making our peace with that in some way, that we are still spirits, and we have to exist in this world without feeling that it's primarily chaos that we are confronting, but that it's something that it's not a hostile universe necessarily. That's just an attitude towards it. Yeah. There's a way maybe of accepting being in it that is more like the poetry Scott talked about, and in whole, incomplete, but also finds a poetry.
Well, is there a middle? I think that, David, that's really beautiful. I like the way you've turned that around to say, because I hear that quite a bit. This is a hostile. We live on a hostile planet. It's we're fragile creatures and all these kinds of things. But where my mind went was our adaptive phylogenetic chain pushes us to the exact point where we are today. So we're perfectly adapted for our environment, and what a marvelous existence we actually have to even be aware of the existence. Like, it's such a miracle, I guess, right? I don't want to put anything from a religious tone into that. It's just a fucking miracle.
Well, you said that. I can't believe it. But we say, here we are. Yeah, but it is a miracle. But so I'm with you, but I think that was the part of the vision of the 18th century, that far. But then came plastic. Then came oil. Yeah. So we're not perfectly, what's the word, evolved to survive, and the other. We have that hostility of, well, there's radiation, and there's Schrodinger's, and there's indeterminacy, and there's incompleteness, and there is it's in front of everything that would make us feel that it's solved with us fitting in. So that's all. That threat. You know, we become artistically comfortable with the action and make ourselves okay with the fact that we're being torn apart as we live and everything else.
Well, the problem I have is that we become so arrogant about our own understanding of other things that, in a sense, we have disrespected actually nature itself. I mean, it's like so we may have a right to destroy ourselves. We do not have a right to destroy, I'll put in quotes, all those inferior species. I'll put that in quotes because I'm not so sure of the inferior. What I object to the Amish is not the God and the beauty of the whole thing. It's like, why did technology stop in 1820? I mean, why not go all the way back to 1820?
That's right. Yeah, no clothes and no wheels either.
Yeah, but what I'm saying is, like, why is that moment the ideal moment rather than some other moment?
That's right. That's a good point.
Moments.
They should be like Janes and just eat whatever carcasses happen to be on the street.
I think we need a representative from the head of that religion to tell us. It's not fair.
I think Dave brings up a very, very interesting point about oil and everything that to use a Heideggerian term, that machination, this I've often thought about the limits of science. Why not a self-imposed limit, or a self-imposed to say, guys, enough with the space travel for now. We're not against it. Let's why can't we focus here?
They could put a man on the moon quite easy, while people living on Earth are dying of all diseases.
Yeah. Oh yeah.
That's Geezer Butler, Black Sabbath.
Well, we remember the atomic bomb. I mean, like, what is that? The guy who was ahead of it, he only apologized afterwards. Before, he wanted to know. He wanted to know, and there was a warning. There was kind of a warning because before they exploded the bomb, perhaps the most knowledgeable person was the guy in Chicago, the University of Chicago.
Fermi?
What?
Enrico Fermi?
Yeah, Fermi. And he said, nobody knows, but the odds might be that 1 in 10,000 all of
chain reaction. They thought there might be a universal
maybe
chain
like
reaction.
1 in a million, a chain reaction in the atmosphere that will destroy everything. Of course, it turned out to be wrong, but that was the best knowledge at that time. And they said, no, we want to know. We want to know.
That's
right?
like the what's the experiment where the experimenter said, turn up the voltage more. It's okay. He's not going to die. And then what was it?
I don't know.
That was something that was I think Stanford.
Yeah, that's right. Milgram. It was the Milgram. The Milgram.
Oh,
no.
Right. Yeah.
Anyway, all right. Well, here's the next video. This is one of Dan's. I don't know what this.
The scientific references come thick and fast now to the troublesome problem of finding the longitude at sea, to the invention of the differential calculus that Newton called fluxions, and, of course, to astronomy.
I am not at present disposed for experiments.
Do you deal in longitudes, sir?
I deal not in impossibilities. I search only for the grand elixir.
What do you think of the new method of fluxion?
I know of no other but by mercury.
No. I mean the fluxion of the quantity.
Greatest quantity I ever knew was 3 quarts a day.
Whoever cast Newton was very interesting because he kind of has that facial structure, right?
Right.
And I don't know what that German accent or Austrian accent was. I think he kind of, I don't know if he butchers it or what, but it sounds a little bit odd.
The humor is so bad, it's like the Monty Python parody of Oscar Wilde. Remember that? Noticing that a banana split is not a banana split. It's really.
I was thinking Monty Python for sure.
So here's the meditation that I want to have everybody think about for a minute. Was that I'm thinking about the ridicule and the satire of the day, and I'm trying to think, you know, what veil do we live in terms of the ridicule and the satire of the day that, you know, in 400 years from now we can say, well, this was just ridiculous, and I could put forward a few suggestions that I think it would be. But what are your guys' top three of
popular culture doesn't know scientists anymore? I mean, when's the last time, like Carl Sagan? They made fun of Carl Sagan on SCTV, and Monty Python made fun of physicists and philosophers. But in popular comedy and satire, scientists are, I mean, the Republicans are trying to make Fauci look like he's evil because he doesn't like killing people for Trump. So there is no scientist in popular culture anymore, is there?
I think it could go, maybe look at the whole thing upside down. When Elon Musk, you know, has enough resources basically to run the world because he has cornered the market on electric cars, and he has the only transportation to Mars, and, you know, basically he's controlling space. Okay, so it's going to be he's going to make everyone look stupid compared to him when the history books are written, because he's going to control the publishing resources. No, it's all a joke compared to him.
I think the satire is to invent it. Well, I was going to say invent a television show after Saturday Night Live called Sunday Morning, which we already have with the Christian fundamentalists, right?
Wait, hold on. I'm interested in David. So Musk is going to control the publishing resources on Mars? Is that what you're saying?
No. He'll have the resources to just on Earth to take control of whatever he wants. So he will make sure that the future history books portray everyone else as a clown, and he's the genius with all the ideas, which, you know, if they happen to kill a lot of people, so, you know, but that's okay. His ideas will be the historical trend. Everyone else will be a laughing stock.
That's right. You forgot the other aspect of the tripartite sort of evil genius plan is the neurons work, the neural link, right, where he's putting the filaments into your skull to try and, you know, help with augmenting your artificial shared intelligence or something like that.
Has everyone seen the chimp playing Pong with his brain?
Yeah.
And he'll say, congratulations, your mind just bought a Tesla and transferred all the money to us. Congratulations.
It'll make purchasing less. There'll be less and less effort involved in purchases. This is my prediction.
That's right. Don't push a button. Just visualize it, and there it is.
And every time you get a Neuro update, the preferences will automatically check off purchase when thinking about by default. You know, like that.
That's right. Where's that damn default? Can't reset that.
So here's something kind of speculative. I think it would be more of a psychological interpretation of Musk, right? I mean, you know, like what's the extent speculative wise about his, you know, quote unquote genius? Like where, you know, what is it that's doing this? Is it just a drive to not, you know, for novelty, to not do what hasn't been done, to do the biggest thing possible, to climb the mountain that hasn't been climbed, right? Is this the algorithm that's continuously running behind somebody that is actually good at bringing resources together, cash or whatever? What's the magic recipe? How would you describe that thing, that essence that is Musk?
It's interesting. You're asking how he's dancing on a log. I have no idea. Right? His business acumen, apparently he has enough successes that he can make all the errors he wants. And he knows how to hedge against that. How the hell does he do that? I mean, it's like Amazon, you know, they went in the right direction, a little bit ahead of anyone else. No one will ever catch up that light ray. Boom.
That's right.
It's out of here. Now, you know, we need electric cars. The whole world knows we need electric. Now, maybe all of Europe will dedicate itself to the electric battery and become the manufacturer, but there's no doubt. I mean, we all knew it. He decided to do it.
Yeah, same thing with Mars. Mars has been the next stop since the moon, and I mean it's inevitable.
But what's the payoff there? That I'm a little A little bit.
No.
Not
What was the payoff in going to the moon besides intimidation?
well,
No,
we all paid for that, but I mean, in terms of Elon Musk gaining more power, different question. We learned a lot going to the moon, and we fended off fear of the Russians.
No,
Well, don't you think rich people will pay? I think Musk's first revenue will be tourists. Don't you think?
No, I think the real step now is when you come to in a way the inner history is what will happen is that spectacle is the thing that will win out, because even comedy no longer exists, right? So you play up whatever it is. I kind of partly learned this when I attended just a meetup group of the avant-garde, and they were, this particular one, criticizing Stravinsky, which I sort of semi-like. I actually like Stravinsky, but I thought he was a kind of avant-garde thing. But they pointed out that even when he did the avant-garde thing, it was really kind of a spectacle rather than real avant-garde, you know, by having all this primitive stuff and play it up. But what after his avant-garde period, he actually turned back into a neoclassical period, which is sort of like very interesting, you know, like maybe he was a neoclassicist trying to compete in a sort of a avant-garde world, and he sort of pulled it off with the Rite of Spring, you know. Well, I still believe in the Rite of Spring, by the way, but it was kind of an interesting insight and criticism that was just a spectacle rather than a real invention.
Well, his avant-garde is very much music, commenting on music and making fun of music and its role, and it certainly is not elevating the human being. It's taking rituals and showing how you can destroy human beings in a ritual and watch it now and feel glorified in the destruction of people. And it's like, it's a really strange thing, and he knew how to do that powerfully. He's a great musician, but you know, in terms of what he did developing music, it's very much being ironic about music, making things sound
that's right,
so strange for what they are as they play out. And you know, every joke that he's embedding in there, it's like, music told you this. I can tell you the joke behind that one. And listen how this bassoon sounds at the beginning of your Rite of Spring. What is that? I think that some Berlioz or someone said, "What instrument is that?" You know, couldn't recognize because he twisted what music did, and satiring life, but not giving you really something beautiful about it, giving you something really ugly. Right.
Yeah, but on the other hand, the true avant-garde was Schoenberg, but it's hard to listen to Schoenberg, you know. So that was a problem, right? So spectacle could take over.
Yeah, I'm not sure what avant-garde means. It sort of means the frontmost group, right? I'm not sure.
Well, no.
Direction, but you know,
no, he actually invented a new language, right? It was very hard to listen to.
Yeah,
you know, he put atonal music into a kind of system. In other words, kind of like tonal music had a system.
I think that there's a function of the avant-garde. So I think that the avant-garde is like the Duchamp taking the urinal and putting it on the wall, the art piece, right? It's about saying to the art world, guys, wake up, give your head a shake. And I think it's kind of like, okay, I get it. Now let's get back to art. That's how I look at it. It's like a wake up call, a shake up. You know, from that emerges new pastiches to the things that, as David said, helps elevate the human spirit. I mean, you know, that's kind of how I look at it. So it has a real function, right? It has a function.
Well, no, I think the Dada movement in general has the function of, let's say, displacing you so you don't fall into a static mode. All right. So even the avant-garde, for instance, you take Cubism, it eventually became Mondrian, right? Classical modernism, which in a sense froze it because Mondrian became the high priest of modernism. So what you do is what Dada is, you come along and you take the system and you give a kind of a whack to
well,
break it back
and they were doing it for,
to break
but
it
they
back
weren't trying to
up again
refresh
so that it
art.
would develop.
Yeah, yeah, but they had it was entirely political. The whole thing was a protest against World War I. It had nothing to do with refreshing like the modes of art. It was just like, it was like punk music. It was like Jello Biafra bitching about the war. The whole thing was to let people realize that they're being fucked and screwed over.
No,
I would take Daniel was saying, and hope that actually you're expanding the horizons of art, so that there's more room to produce beauty. Why isn't that the end? You know, the elevation of humanity.
No, that actually, Duchamp was very much about beauty. But what he was doing was that every so often, I think of Duchamp as really like a Zen master. You know how a Zen master, sometimes he teaches you things, but sometimes he just whack you in the head. You know, I mean, like, and that's the Zen koan, right? It's kind of like, oh, like, what the hell's going on? And so you have to be reawakened from your stupor into the tradition. So I think that's very necessary. You can't just keep whacking the guy over and over again, but at the right moment, like, you know, you're falling into a habit, right? So therefore, it really relates with a new language that allows you to expand because you don't fall into a trap of stasis.
And actually changing the personality of the viewers. I mean, they were trying to actually like remember Eisenstein, he wanted the Potemkin to break through the screen, and he wanted the revolution to spread from the ship into the audience, and he wanted the real communist revolution to occur. So in the early Dadaist pieces, they would lock the people in the room, remember, by covering the door over with wooden planks, and they handed axes and hatchets out to the audience members, and they had to hack their way out of the building. So I think we need that kind of like quality art that gets people off their apolitical asses and gives them a sense of, I don't know, potency. Maybe they could vote or strike or do something. Anyway, well, on that optimistic note, here's the last video. This is the Einstein one. This is the sweetest.
Albert.
But he was a man who thought for himself. He went to the heart of the question, which is, how in fact do not physicists, but human beings communicate with one another? What signals do we send from one another? How do we reach knowledge? And that is the crux of all his papers, this unfolding of the heart of knowledge almost petal by petal. So that the great paper of 1905 is not just about light, or as its title says, the electrodynamics of moving bodies. It goes on in the same year to a postscript saying energy and mass are equivalent, E equals mc squared. That comes from a profound insight into the processes of nature herself, but particularly into the relations between men, knowledge, nature. Physics is not events, but observations. Relativity is the understanding of the world, not as events, but as relations.
Yeah, did everyone have that experience when they first learned relativity, special relativity in school? And they started talking about the observer this and the observer that. And remember that? You're like, holy shit, that's right. All this time we've been observers. Yike. And then you realize that now suddenly the subject is coming in. Yeah, that was profound to take relativity and make it into a foundation for derivation instead of like an oh yeah, and then you just ignore it.
Now, I will point out, maybe this is kind of a film move, but the idea was after Einstein's ideas became somewhat popular, the idea of relativity actually was trying to be assimilated in many areas of life that it wasn't necessarily valid, right? It didn't map on in a similar type of way. Does that make sense with everybody?
I thought he overplayed the relationships, because at the end we see Einstein is playing a violin. You know, like he. Okay, I'll take that for granted. That's good. It was not only inside the thing, but also expanding human relationship. What I found interesting was both Newton and Einstein, very much geniuses of the period, were in a sense geniuses that only took a half step, because Newton was tied to alchemy, the classics in a way, and he stepped into the future and actually opened up the door for other people to follow. And Einstein thought he was like Newton was falling into trouble. He was trying to save Newton, classical dynamic mechanics, and that he turned out to actually open up a new space where the quantum physicists stepped through the door and said, no, it is, and it's something different, and you don't understand what you've opened up. And he said, well, God does not play with dice with the universe. And they say, yes, he does. So that was interesting how, like, revolutionaries in a funny way only take a half step, and it takes another generation to take it on the whole step, and then of course it needs to be developed, and then it takes another genius to take the half step into another. So they opened the door, but I'm not sure whether they fully stepped into it. That's why I think he remained secretly an alchemist, Newton, and Einstein thought he was secretly saving Newton, but in fact he destroyed Newton and opened up the door.
And Scott's point to I'm sorry, with Daniel's point about the overuse or overemployment of the term relativity, which still goes on, right? I think we see that with quantum. Everything is a quantum now. Quantum thinking, quantum computing, it's going to do everything. Everything's quantum. To explain everything, uncertainty is uncertainty. Even when it has no application, everything is Heisenberg uncertainty, right? As though we visualize the Schrodinger equation and know what's going on. So
it's in everything, yeah. If self-help systems, medicine, water beds, everything has a quantum, with quantum technology. Just say quantum and then raise the price with $9.99.
Relativity is sold out. It's only $1.50. Quantum's still at $20. You add that on, you got a lot of profit.
So
that's
is that
the difficult thing to do, latching onto the rocket that's taking off, right?
So is that a limitation of popular culture or regular culture who doesn't understand it? Or is that attempt for regular culture to somehow try to understand it in almost a poetic way? In other words, you can't understand a damn thing. All you could do is like create this sort of equivalency of sorts, right? So maybe that's a new language in a funny way.
Maybe no harm in expanding the ideas, but the big flat ideas are not necessarily really the ideas embedded in the science itself. I'm not sure that the notion of uncertainty, the way it's depicted, really has anything to do with people or understanding, right? And some of it is like you're selling snake oil. Okay, if there's no mercury in the snake oil, it's okay, sell it. But you might be killing people with a bullshit description of what it is you're doing, and they're going to believe it and buy it and not take vaccines and do all kinds of stuff.
No, I think you're asking too much of regular people, because to ask them to truly understand it, something that they cannot understand, then in a sense they have to make some sort of generalization in order to create something that they could connect to, right? Because
you'll have to guess about
understand the mathematics. Very few people. Maybe
they're not ready to understand relativity yet.
There's an actual history to it. In the beginning, no one understood it except the developers, and then a few people at universities understood it, and then Fritjof Capra wrote The Tao of Physics, and then you had a subculture of people that got it, and there Gary Zukav and Frank Herbert and Fred Allen Wolfe wrote their books popularizing, and then more people knew about it. And then Timothy Leary, Robert M. Tim Wilson, they started talking about it. And now you've got this really bad What the Bleep Do We Know documentary. People watch that, and then they think they understand it, but it's misapplication. They're taking certain interpretations of the collapse and then turning that into a metaphysics that but actually there's no settling There's no settling beyond the Copenhagen interpretation. Everything else is a guess. Does the subject do it? Is it actually still in superposition forever, no matter how many boxes and zooming outs you do? They don't know what's going on. And now it's used as a synonym for God, consciousness, and freedom. So when people want to say God, consciousness, and freedom, they say, well, actually, the quantum realm is what allows for these acausal, self-aware, things that are outside the billiard ball model. Quantum mechanics is it's like the gap that holds God. God's before the Big Bang now. So quantum mechanics is the gap that allows everything that we care. I mean, maybe poetry and value and emotion and meaning, that's also in the quantum realm.
Like God needs a gap, like poetry needed an explanation, like Mozart needed you to explain him. Yeah. It's just the same mistake over and over. It's not that there's not beauty to the theories and the things that these guys are visualizing, but it's so weird to see people applying them, with a shade of understanding, really. I mean, understanding space-time, it is not easy. There's like how many people understand general relativity at any level, and it's not like quantum mechanics, which you can't understand.
Yeah, but on the other hand, nobody still truly understand what God is. I mean, it's like we still don't even understand the old concepts. But people want to understand something, be connected to something, so then they could be snow and be corrupted by the church, who could steer them into that's what God is. So in some sense, there's also a problem if you really want to truly leave it to the people who truly understand. Then in a funny way, then you're leaving a world that's just going to be governed by technocrats, right? Don't even bother trying to understand this. We'll take care of you. We'll solve all the problems. So we don't want that either. So once you get into that situation, it's hard to know how to get out of it.
But again, I don't think anything. My presumption that. And nothing's changed. Science is telling you how to do stuff. Doesn't tell you what to do. Doesn't tell you why. Doesn't tell you what's beautiful. Doesn't tell you what's worthwhile. You want to know how to do it? Okay, ask the physicist. Do you care about his theory of where it came from? He doesn't know. But he'll tell you what he can tell you about the physics that can be measured, okay? Anything else, he's out there speculating. Take his hat off. Remove his bars. He's off duty. Fine. Let him speculate in a bar next to me. It's okay. But when it comes to values, we're not talking about that. We don't mind having people who can answer questions. I'd like to know what size pipe to use and everything else. The right vaccine. I'm very grateful.
Yeah. People aren't comfortable with the generic idea of a mysterium tremendum. They want to fill in as quickly as possible with their favorite mythological deity or their favorite misunderstood physical theory, because the mind demands intelligibility. So on one hand, we're resting on something that's obviously infinitely mysterious, but our cortex wants predictability and it wants intelligibility. So I think it's noble. I think it's a noble task that the human is confronted with infinite mystery. It knows that it'll never be able to actually map it out, but it can't stop trying until it dies.
Well, the limitlessness, right, Phil?
Yeah. No.
There we go, David. Nice tie-in. That was beautiful.
Yeah. I think if people understand truly that they live in a world of limitlessness, but they have to operate in the world of limits, then I think that you at least have a kind of equation to deal with life.
Well, so science helps us, because then we see the speck. Sure. That's the little globe that everyone's on that. And then we look around and it's like, that's a little teeny speck, because, we're looking through the rings of Saturn and it's like, oh, whoa, that's a nothing, back out. And that's just, it really gives you that feeling that it's limitless.
Yeah.
Pro science.
Yeah. I think this dichotomy of pitting science against something is a remnant of the Enlightenment, right? I mean, science had to distance itself, right, to become the dominant sort of thinking. But we somehow have a lot of people that still think that it's like, well, wait, the other side of that is this dogmatic thinking, this, you know, this magic that we can't explain what the color blue means, or, you know, what it feels to, like, you know, to listen to an opera, if you're into that sort of thing, right? Like this music or this art that changes us, and it's something that we can't quantify with science, right? And so it's perverse to me that the default tradition, the default for that response is in the traditions of like a religious or a mystical kind of thinking. And I think that's, I don't know why it needs that label, really, right?
Well, in the other end, it goes to the MRI, and they're going to show you why the music works. And that is equally, it's the opposite end, right? They're both the wrong end to go to, right?
Right.
Well, no, I think of it differently. I think if you could understand the difference between an aspiration, you know, you want to get to the unlimited as an aspiration to reach for that, and what really is, then I think then you could dispense with things like religion or all sorts of things, because they tell you an aspiration that should be an aspiration, but you make it a kind of a physical manifestation of the real. So if you could separate, I have no problem with people wanting aspiration, because we all want that, right? But the aspiration is what you hope it could be, or what you wish it could be, what you reach for. But on the other hand, you live with apples and oranges, right?
That's good. That's the perfect Kantian answer, isn't it, Dave? That you have these regulative ideals that act like asymptotes that drive our theorizing and our willing and our desiring and our valuing. We're projecting these asymptotes and then running towards them. We're dangling a carrot in front of ourselves, but the carrot is an innate dangling by the organism. We'll never be able to realize our fantasy of a grand unified theory, or a fantasy of a theory of everything. There may not be such a thing. It may not be on a t-shirt, but we can't help. We hunger for that kind of unity.
Yeah. But we need aspirationally to keep it infinite. We need to have a place that we know we haven't reached, because if we think this is good enough and the only answers are these three answers, and we're going to put up with that because the corporation's the only ones who can feed us, if we believe what we see and we can't get beyond what's obviously the case and realize there are so many possibilities we have not taken into account that matter, because what ultimately matters is ultimate, then, you know, we need the ultimate, we need the infinite, we need God to be beyond everything all the time. You know, in that sense.
I don't know if this is the way Nietzsche looked at it in terms of the Übermensch, but we're querents, right? We can't help, like what Scott's point is, we can't help but ask why, right? This is kind of, I don't know if this is just the label that maybe the Greeks put on Western philosophy, but we can't help but ask why, and you know, I'm kind of just speculating here. Is like the next leap to the new version of the human is what, the version of the human that doesn't ask why, that just exists in a plane of, I don't know, like.
That'd be you're talking about a dystopian anti-hero human. That's right. Yeah, in the Orwellian or the Anthony Burgess version of this story, yes, right. Capital will produce people who no longer think critically, who are good, patriotic producer consumers, and with as few mediations in there as possible. Unless they're moving their bodies through the cilia of a shopping mall, then they can have value extracted from them. But besides that, yeah, maybe that'd be a dystopian answer, the non-questioning person.
No. You could have another culture, and China produced it. Which is Confucianism, right? You have a system that orders what things are, and to a certain, you know, China was moving quite ahead, but then, you know, that at some point, you know, like in a sense, Confucianism froze the society, because, like, you know, everybody behaved, and that was in a way an aspiration to be a kind, respect for society. That's sort of like, because order and stasis became something that would sustain itself. That's one of the reasons why China has lasted a long time. But the problem is also produces its own problem, which is the suppression of women and all sorts of things, internal conflicts between the various tribes, like Tibet. I remember when I was in Youngstown, I had a meeting, and there was a couple Chinese who came to do research, and we have a little Chinese meeting, you know, and I was invited, and for some reason the topic of Tibet came up, and you know, and I spoke up. I said, well, you know, whatever the Dalai Lama says, you know, I'll go along with that, and immediately they knew that I was not Chinese. I looked Chinese, but I was not Chinese, and so China does have this thing where you believe that the overseas Chinese should still be Chinese, right? So therefore, in a sense, there's this thing about the whole of Confucianism, and I don't think that's an evil plan, but it's something that sort of created a stasis because that's what they want.
I don't know how. I don't know how that philosophy works with people who have minds who are free to think. So, you know, if you have to give up your freedom to think and reflect and reason, basically its urges, then yeah, that could work. Or on the other hand, maybe it could be a satisfying system if there are ways that everyone is provided for, everyone is caring and taken care of, and yet there's still room to say, how can we make it better? Why would we, you know, what do we want that's more? Why, you know, so the whys are possible. I don't know that you can give up being a human who does the why. I think Nietzsche really has a point, because you acting in the world is an expression of why. Anything you do is because of your internal doing.
Well, the Chinese
if you look out at the world and don't look at it that way without purpose, then you're the only one with purpose. That's really, you know, a kind of a limiting view of the universe, that there's no purpose, other people's purpose, and there's no way for you to engage in a universal purpose.
No, the Chinese actually had that, because I think of I kind of think of Chinese as having the poles. Confucianism is in the weekdays, and the weekends you become a Taoist, right? In other words, so in a sense, there's a major, minor, mole. In other words, Confucianism gave order and stasis and rest. Everything functioned nicely. Nobody got onto each other except the Tibetans and other tribes and so forth. But in the weekends, you know, you go and think about the eternal Tao and all that. But that was in the weekends. We kind of have that in a way. We have a weekend which you could, except what we do is we go sunbathing. But nonetheless, we have a weekday and a weekend. So in a funny way, they had that. They had that balance. They do let you, and the people who are intelligent and smart, they actually do spend a lot of time being Taoists as well.
You can't kill it, right? So it's interesting. What you really said is there's a harmony. There's a way to balance.
That's right. A harmony. Harmony.
So that brings me back. What was Daniel's question then? Because we're visualizing not someone without a why, but someone who balances why with good and life and presence and, you know, living 5 days of the week and all this other stuff.
Well, look, this is the kind of thing that I think is what makes Nietzsche's concept of the Übermensch really interesting. And I don't know what he envisioned this next new superhuman to be, right? I would assume that it was something that was very self-aware and I guess self-determining, I guess. You know, because you're talking about something like a new kind of human, basically. It's like, to me, he's describing something that is like the human in 300 years. What does that human look like, right? For the better. Like, what is, it's like.
They teach a class on this in University of Hawaii. It's called like transformative literature. And the problem is, if you talk about constructing a new type of human being, then we're not allowed to talk about what the experience of that new human being is like, because it's actually a transformed human being. And they talk about psychedelics. Like, if you take this psychedelic, it'll produce a radically new transformed consciousness and point of view. What's it like? Well, if it works, then I can't talk about it. Anyway, that's one of those paradoxes. If you talk about if the Uber in Ubermensch is really an Uber, then there's one thing that we know, and that's our speculation is now useless.
Yeah, we're down on the sub-Uber.
Well, but wait a minute. What if I were to say something like I've thought about this before, where you have the evolution of our biology, right? So in 100 years, not much change. 500 years, not much will change. 2,000 years, we're just still talking about cultural evolution. There may be slight. There's a constant change in evolution at play, but for us to transform into like that newer form of move from sapien to the next, like what is it? Is it a singularity with? I'm not saying what it is. I'm saying that there's an inevitability to biology here, that in a million years our biology is not going to be quite the same as our biology is now. One thing's for certain, it's not going to be the same.
Yeah, but like I wouldn't like this future, but nonetheless, it seems to me some people believe in being androids. That we are on the verge of creating a new species, which is a synthesis between that. I don't like it, but I think that might actually happen. In fact, it is happening, right?
I agree. I think it is. I think a singularity between humanity. We're modifying the environment through technology, and the technology will change us, right? It'll implement into us. It has already.
Mm-hmm.
So, if you think in 500,000 years from now, what are we going to be like? What is the human race going to be like if we haven't, obliterated ourselves on the planet?
I sort of abhor the idea of it radically changing. On the other hand, I'm sitting here with my glasses, and I have a titanium fibula. So I guess I have to I guess I have to admit things are coming faster.
So Phil, what's the matter with uploading yourself into a superior infrastructure that doesn't age?
I don't know. First of all, while I don't like it, I think death is actually proper, because
so just prejudice. That's pure prejudice.
Yeah, I know. No, it's not pure prejudice, because I believe in others. If you imagine if we were that way and we were selfish, there would be no more new human beings, because we'd be occupying, so in some sense, there's also a more generous way of seeing, like, you pass away so other could come into being. So I don't like that on one level, but on another level, I actually do like that, because that is the process of sharing. But on the other hand, I just don't like. I think that the human being still could change without the help of so much other devices. So that's why I hope. But on the other hand, it might take a very long time, certainly longer than I'll be around, right? So maybe the mechanical addition of being an android will make it go faster. So but I think the android would be more like Terminator 2.
Do you guys know? Do you guys know that I'm working on a novel called Will Freeman? I think Scott does. So Will Freeman is it's an AI novel, and the premise behind the novel was that there's so much in our popular culture about artificial intelligence being the boogeyman kind of thing. So to set the stage for the novel, we have an impending reality that humanity is going to be snuffed out. It's going to die. We have an expiration date, right? Mm-hmm. And so science is now humanity looks at technology as our savior kind of thing. I'm not trying to make it with any kind of religious overtones. What's with me tonight? Savior and miracle, Christ. So anyways, you have this shift from mindset or mindset with humanity to say, well, we actually only have X number of years left. How do we somewhat try and encapsulate humanity and put it in something that someone will discover, right? Like that was kind of the idea behind the creating an artificial intelligence that actually represents us as closely as possible. So a biological substrate, something that has pleasure and pain, something that has pretty much the entire cultural awakening, say from the ancient Greek onward, right? In their memory banks or memory system. It's a part of their being, their existence, their tragedy, the feelings that you know, through all of our culture is kind of captured in that artificial intelligence, right? The question is like, how do you do that? But that was the idea, and this is our one last attempt to be able to leave something when the biology is wiped off the planet.
I think that was already in a Star Trek episode.
Oh, I love that argument.
When this mind was waiting to be discovered by Captain Kirk, and with the additional knowledge. No, I'm not putting down your novel or what it is, but I think it came very close to what you're saying. Is that some other species that was sort of humanoid had already recorded all that knowledge of what it is, and it took Captain Kirk and Spock to finally find him and learn the stuff. And the guy was telling this mind was telling him about what it is. And I think Spock or Kirk said, "Well, that sounds very much like us," something of that sort, which is sort of interesting.
Well, the interesting thing I think is that you got this problem that most people, when they talk about artificial intelligence or technology or you know, there's a fear, right? There's a fear of it taking us over. I don't know if it comes from like Terminator or, you know, all the popular science fiction that's about technology becoming our overlords, right? But it's a real fear-based response to something that's, you know, man-made. I mean, we've seen that happen before. Are we creating a new God?
We've asked the question, I think, once today already about, I think it was here, my mind, I can't tell, you know, the time-space continuum is very difficult. So whether or not there's a limit on science or whether there should be limits on science, I think Phil said that. And, you know, just, you may have said it too, you know, going to Mars, why don't we go to Mars right now? Maybe there's something important we should be doing before we do that. We need those guys to figure something else out. But, so I got so worried about forgetting, I forgot my whole point.
Well, I'll pick up the point because we already have that. We already have that. It's called the Rosetta Stone. Somebody was smart enough to leave it in actually 3 languages, right? Egyptian and I think Babylonian. I think archaic Greek. So what was it? And it wasn't for the Rosetta Stone, they would not know because they couldn't translate it. So somebody left a record of the language of their civilization that then we could use to decode the hieroglyphics and the Babylonian language. And so that's kind of interesting. So somebody knew something already. They knew that they were eventually going to fade into history, and they left the record.
Can I bring up something to Dave? I have something I want to bring with you just to see if this helps tease out your point. So
I remember the narrow question you asked was, why do we fear the singularity? Why do we even think that there's such a thing? And the guy was saying, think about limits to science. Think about how successful we've been with that. Think about Oppenheimer's regret. Well, maybe this was a problem. We always go past the line before we stop. Okay? So, of course, the easiest thing to do is to build drones and to build armies of things that can kill other things, because you don't want to send your actual guys out there doing that, and to run them remotely. And certainly when an efficient system that can drive itself and use, you know, analytic methods of determining what the other enemy's doing and to do it faster. So you want to develop these mechanisms to destroy human beings. I mean, that's what our military wants. Who does the research and who has the money? It's the military who developed, you know, arrows and, you know, catapults and everything. You know, I don't think they were hunting dear. So that's what we have now. And why would we expect, with the NSA surveilling everything they can as soon as they have a computer that can do it, why would we expect these guys might have some sinister plan, you know, which is really to protect us, which could maybe go wrong? You tell me why. I mean, did Dr. He stop when he was told, do not change in vitro eggs and sperm, you know, fertilized eggs? Do not change them because you're changing the human genome. You can change individual people splicing their genes, but don't change a baby's fundamental cells that will replicate and become the entire human being, because they will pass that down in every generation. You have violated humanity. He knew that. He changed them for the good because he's a good guy. That's what he said. I think they locked him up eventually, or, you know, sanctioned him. If they can do it, they will do it. There are plenty of scientists who are ready to do it. Now, I ask you, this is the dead end. Where's the good end? That's the singularity. It's almost unavoidable considering where research goes in that sense. So I think totally sentient, conscious machines are completely trivial. You know, it's like, yeah, it's going to happen. But what are we against them? That's a little worry. I have a little worry.
So what you're saying is the future does not unfold itself, but the future actually is a projection of ourselves into the future. That's what you're saying.
Are these things ourselves? This is going to be a battle. I mean, I don't know if they will have a Kantian.
Well, the projection of ourselves, because our development is basically to assume that everything is hostile, and we're projecting that, let's say, an alien or a machine will be hostile because we created it and we're projecting it into the future.
I'm not hostile. I'm only hostile to certain cockroaches and certain spiders.
David, are we playing a certain kind of God role with the statement that you've said? And I just give me a little bit of explanation here, okay? So you say, take something like the Homo habilis, okay? And they're at the in a different kind of world. They're in the point in the phylogenetic chain that we're at right now. And they say, we don't want any changes. We don't want to have a kind of sapien hybrid person, you know, population that's going to glom onto technology like we're doing. And you know, like a virus infect the entire, of course, they wouldn't have the ability to conceive all of this anyways. But, you know, they would say, look, we don't want it to go that way. So let's just keep it the way it is. And so it's like we're not even in a position to, well, I guess it's to your point. It's like we're just really not in a position to say anything. There's a certain inevitability of wherever it goes.
It's not that we're acting as gods. It's that we have plenty of power and none of the perspective. And, you know, it's stars that we are underlings, but we have enough power to corrupt ourselves. Well, and we're just following our impulses in doing that, as opposed to becoming like gods and seeing what we're doing.
Yeah.
We're making a projection that somehow that we survive because we're superior. Who the hell knows that whether we wiped out the Homo habilis or Homo erectus, or whether they died because they didn't have the technology to protect themselves from lions? Who the hell knows that if they had survived, that they might not have developed into a more superior human being that actually grew from Homo habilis rather than us, that got diverted into this knowledge game to that degree? We don't know. We don't know. All we know is that now the science tells us that actually the Neanderthal was to some degree inbred within us, but we might have killed 90% and only 10% survived in our genes. We don't know.
I mean, it's I guess sort of, I'll sweep this in one sense. We don't care because we're the ones who are here. I mean, and sort of like, do you want that as the next step? That doesn't care, you know, and they're the ones that are there. I'm just saying what we're building is a little like building Tower of Babel. It's an old story. It's an old story, right? And, you know, it might just sweep us away and not leave us speaking any languages because it's going to be its own thing, you know? We certainly can do technological things that we know the extent of them have never been able to be reached before. We can do them now.
Well,
Thanks.
why is it that other,
Thank you,
why is it
Einstein.
that
Thank
other
you.
But why is it that other species, most other species, have many more living variations, and we only have one, which is Homo sapiens? Why is that? Why don't we have more variety, you know, in our species than that? Most other species have some variety within the genus, and so that's kind of interesting. Like, why is that the case? And why are we figuring out that these other species also will lack variation because we?
Are you saying it's a deficit, or are you saying you're drawing the line around us, saying this is the species, and we're not including anything related to us as existing on the planet? So we're so different from everyone, or is it just, you know, we like other human beings, so we're like inbreeding all the time? It's gonna be one group. Or
well,
you're saying
the point is like you have an ant that has, you know, hundreds of different species, and we've got humans that have one species.
Yeah. Well, there are a lot of ants in the world. How many trillion ants?
Yeah.
Well, look, if we had it our way, we wouldn't have an American Indian problem, because we would eliminate even the subspecies, right? Like diversity is also important, let alone quote superiority.
Wait, hand up, teacher Phil. What subspecies? I don't understand.
No. Well, but the family tree. Our Constitution, our laws actually said it, that African Americans were only 3/5 of a human being. They are human beings, only 3/5, and they only granted that because they wanted the votes. They wanted the votes and representation.
They didn't get to vote. And women didn't get to vote.
But they wanted a representation in Congress. Otherwise, they would have left them as
non-human. You're bringing up a property question. I don't think that's really the same thing.
If we were gonna end the show before, right? We had such a good, nice pin. We don't want to end it on that, guys. Come on, let's.
It's great. I wish I was good at that. I don't know, soupy sales. So no, you're right. We had a lot of difficulties. You were talking about, you know, the end of our species, or whether we're so specialized and there's not enough variation. Maybe it's a very successful variant. You know, we have been able to cure diseases to preserve this variant. You know what I mean? I don't know.
There's a lot of like interspecies war. Like maybe other primates coexist, but when we saw things that were very close to us, we freaked out.
Maybe. And is it a bad thing that we don't have that much variation? On what chart says you must have variation? I know there were a lot of reasons to have variation. You know, you survive bad things in the environment, right? But which ones? Water and what? Yeah.
Can I put one hypothesis here that I think maybe the reason why we've got less variance, I guess. Like, do you know what I'm saying? So yeah. I think it's because we as a species have had the fastest transformation evolutionary, with our cortex going from 600 cubic what is it, cubic millimeters, or what was it, cubic inches or whatever, to we're over what, 1300 now. And so that explosion of that sort of that rapid transformation in evolution, right, coupled with all those other effects, really, it wasn't like there's a guy going, you know, it's just through a total attrition, right? It's like it was.
That's a possible. To simultaneously explain why we have so little variation in our species with the brains, and also why we need Netflix. You know, you've explained both things.
Well, wait a minute. I need to correct you, because Homo neanderthal actually had a larger brain. Now,
But he had
maybe not a more complex brain.
Right.
We don't know. We only know the size because the soft tissue has melted away. Okay, but they actually have a larger brain than we do.
No, but there's all sorts of conversation, Phil. We can get into that. Was the there was a girl who was on our show recently, right? And she brought up a really interesting point about evolution in this particular regard. I can't. Scott, do you remember what the girl? There was I think maybe one of your friends that brought up a point about evolution here.
No.
That's an easy answer, you know.
She evolved to another species.
No, okay, I know what it was. It had to do with the facial features, right? So it had to do with the fact that we can transmit language.
Oh,
like,
yeah.
The
voice box. The voice box.
No, no, that was kind of debunked. Well, the voice box was kind of debunked. It has more to do with the fact that your point about the brain size is one thing, but then there's a body mass index, brain size ratio thing that really comes into play, right? It had actually to do with her point was that they seem to be further advanced in facial communication, so facial expressions.
Yeah, I actually remember that.
Neanderthal. That's right.
Yeah, and that's fascinating to me. So then, like, person to person communication would have been
more
nuanced.
Yeah,
but their ability to transmit outside of their tribe was greatly reduced. So it doesn't mean that anybody was attacking their tribe or had any prejudice against them. It just meant that the system that was anchored in language with the transmissibility that went through generations, ritual-based and otherwise, was a superior form of information transmission. It just
Well, to a certain degree, there's some doubt thrown into that because the Incas, in a way, didn't have a language. They just tie knots. They just tie knots in very complicated ways that actually told you what to do and how to do it. And we haven't figured that out. And while they're not technical as advanced as we are, they were pretty damn technically advanced in building those stone monuments. And they built a civilization that was pretty comprehensive, considering it was just knots. It was just knots.
You mean the written form of what we see?
The written form, which is a lot of
talking about generic communication, right? I mean, Daniel was talking about communication in general, language.
I'm sure the Incas knew how to talk, but what I'm saying is the written language was knots, which is sort of interesting. Like, how could you build such a civilization and just tying a bunch of knots? I mean, like, it's definitely more than Boy Scouts.
That sounds like the Frankfurt School to me.
Hierarchy.
No, they did not. They did not. I mean,
I think their trick was hierarchy. I think.
I have a question about the video. So remember that part where he says they made satires of Newton, they insulted him, and then he said, "Rightly so." Because Newton had a prejudice that space was absolute, remember? And Leibniz said, no, you've gone too far. You've gone past your principles. You've assumed too much about the nature of space. And so all my life, I've tried to be sympathetic to Leibniz's notion that space is nothing but kind of like a spillover from certain types of mental activity where we focus on actual things. So there's an actual point A and there's an actual point B. But there's no span A-B, and so the spatial span is something he calls it a well-founded phenomenon, and what's really it's a completely relative view of space. It's so relative that there is no space.
No, I got something a little different from that. I thought that he actually used that as an introduction in a funny way to Einstein. Because he did.
That's what he used it for. He used Leibniz as a bridge to the Einstein segment. But I thought that was so lovely that he would bring up a Leibniz because most people don't know his theory of space, but everyone does know that there was that Leibniz-Clark correspondence fight between the Newtonian absolute space and the Leibnizian nothing space. But I wish someone would make a YouTube video that would actually let me experience what Leibniz was thinking when he was convinced that space wasn't an intuition.
Well, but it's pure relations between things.
Well,
Space is what we make out of the relations between things, which is sort of, you know, its scientific meaning. What does it mean that something is further away? It means it takes more reach, more time, more you know, motion to get to it. That's all it means. So I mean,
but that makes time into the stuff or the medium that separates A and B.
Yeah, right. Well, that's why he brought that's why he brought in the map making thing, right? The map making thing in which the curvature of space was very, very different than flat. And despite the fact that I think, well, certainly Newton knew that the globe was spherical or somewhat spherical, and yet he insisted there was a flat space. So therefore, the curvature was just an object that was in this flat space. But you know, but Leibniz sort of realized it was curved, and I think because it translated in time, he made a brilliant connection that I never thought of. That actually that was the precursor of Einstein. The space is curved and space is related to time, which is sort of interesting. I'm not sure if that's actually true, but nonetheless, it led to a new insight.
Of course, it is related to time. But Scott, back to your point where you were saying that about time, as that it then informs our cognition of reality, right? Where you take time. So are you kind of are you trying to get behind time or use something in replace of time? And like, where do you see our moves there? Yeah.
I mean, our subjective time is our little proper time. It's our foundational time. So it's how we frame relationships to everything around us. That I can get to it, I can't get to it. I get to it right away. I'm in contact with it, and I'm in now. So it's like no time. Like it's an enduring contact or it's stopped. You know, so those periods of time make sense in terms of my relationship to everything. So time and space are this relating to everything in the same way, but you know, one undoes the other, right? But to see how they would work out mathematically, good luck. Get out your protractors and your, you know, rulers and start measuring light.
Well, but isn't there a problem because the whole thing about the round globe inspiring the space's curve and related to time, isn't that a localized phenomena? How do we know that when you go further away, that space is still curved like the Earth? Are
you talking about Einstein? Or are you talking about Newton and the curving?
No, I'm talking about Leibniz inspiring Einstein. Okay, it gave that analogy that space and time is related, but it's only related necessarily because it put it in a local situation, which is sort of like relationship from one local area to another. But that was in a very short span. How do we know, you know, like a million light years away, the space is also still curved? We don't know.
That's right. Let me show you this. This is from Brian Greene's little video essay on space. I know you've probably seen this because it was on Nova. It's got the best production values of any documentary in history. Let me show you this 30-second segment on space. That's really
Phil, curvature's local.
Okay, good.
To a degree.
But there's something important here that you won't find mentioned in the playbill. Something we hardly ever notice. The stage. It's an absolutely vital part of the show, and yet most of us, we don't even give it a second thought. But Isaac Newton, he did. This is how the father of modern science pictured space, as an empty stage. To Newton, space was the framework for everything that happens in the cosmos, the arena within which the drama of the universe plays out. And Newton's stage was passive, absolute, eternal, and unchanging. The action couldn't affect the stage, and the stage couldn't affect the action. By picturing space in this way, Newton was able to describe the world as no one had ever done before. His unchanging stage allowed him to understand almost all motion we can see around us, yielding laws that can predict everything from the way apples fall from trees to the path the Earth takes around the sun. These laws worked so well that we still use them for the things we do today, from launching satellites to landing airplanes. And the laws all hinge on one radical idea: space is real. Even though you can't see it or smell it or touch it, space is enough of a real physical thing to provide a benchmark for certain kinds of motion, like that skater. Newton would say that when she spins, her arms splay out because she is spinning with respect to something, and that something is space itself.
Philosophers have been debating the nature of space for a very long time. What Newton does is change the terms of the debate. And with that, essentially modern science gets born.